Okay, so we want to use the previous data set, the one that we've been using for the other examples, to find the percentile and z-score for the data 14 and 25. So the first thing that we want to do is we are going to do the percentile for 14 and for 25. All right, so let's check the definition. And it says that a percentile of a specific data entry of a given value is the number of data that is less than the given value divided by the total number of data in the set rounded to the nearest whole number. So if I come back and I use this data set, well, counting the number of data that is below 14 is difficult because this is not in order. So what I am going to do is I am going to type sort and then go X1, and that will put this list in order from least to greatest. And it also tells me that it's a 19 element list, so I know the total number. Now the reason I picked 14 is this, and I know I'm being a little bit nitpicky here, but you'll notice there are 3 14s there. And the definition says it is the number of data that are below that number. So I don't have to make a guess as to which 14 they're using. I use none of them. I am only counting the values that are below. So in this case, there are 1, 2, 3 values below 14. So when I go to make that calculation, my calculation will be 3 over 19. And then I can use Desmos to make that calculation. Just go 3 divided by 19, and that will be 15.789%. Now it says to round to the nearest whole number, so we're going to make it 16% because the 7 is going to cause us to round up. So in this case, I'm going to say that we are in the 16th percentile. Now, I don't need to retype all of that. I can just come over to here. Now, to calculate the 25, I'm going to make the same count. So I'll count all of the values below 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There are 17 pieces of data. So I'm just going to highlight here and change that from 3 to 17. Now in this case, it would be 89.474%. And since the 4 is below 5, we would round down in this case and say that the percentile, and I'm just going to rewrite it here, would be 17 out of 19, which would give us the 89th percentile. Now to find the z-scores for 14 and the z-score for 25, let's check the definition. The definition for a standard score or a z-score, it represents the number of standard deviations, which in this case is the lowercase sigma. A value x lies from the mean, which is lowercase mu. So here, the x value, that's the values that we're looking for. So in this case, for this formula, we're going to plug in 14 and 25, and then the mean will go here and the standard deviation will go there. Now we don't know those values, so let's use Desmos to calculate them. Now for the mean, I'm going to type it in this way, and I'm going to just follow along, and I'll tell you why I did it this way. I'm going to go A is equal to the mean of x1. And then I'm going to go B is equal to the standard deviation. And since they don't tell us that this is a sample, we're going to assume that it's a population. Hopefully when we get to other things, they'll tell you directly whether it's a population or a sample. But in this case, we're going to go x1 again. And so I have these two values. So let's go back here and just write these down so you can see them. Here I had my mean was 18.158 and my standard deviation was 4.522. So my z-score for 14 will be the 14 minus the mean, which is 18.158, all over the standard deviation, which was 4.522. And then the z-score for 25 will be 25 minus the 18.158, all over 4.522. Now, going back to Desmos, let's talk about why I went A equals and B equals. I want to be as accurate as possible, and I don't want to round if I don't have to. And by typing in A equals into Desmos, it actually puts all of these decimal places into A. And I can use A, and anytime I type in, and I'll just do it, A, I get all of those numbers in there. So if I want to do, and I got to do parentheses because I got to do a subtraction in the numerator. If I want to go 14 minus A, close that, it subtracts all of the decimal places away. Divided by B, which is the standard deviation, that gives me negative 0.919, because I would round down. 0.919. And then if I want to do 25, I will just change this 14 to 25, and that gives me 1.513. And how do I read these numbers? Well, I can say that 14 is 9.19 standard deviations below the mean, and 25 is 1.513 standard deviations above the mean. And what that tells me is because neither of them are more than 2 standard deviations away from the mean, neither of these values would be considered unusual. Okay, moving on.